Hello again. It's now time for the second part of 10.5 about linear functions. Part 2, the sequel. Okay, so last time you learned how to identify the m and the b, the slope and the y-intercept from an equation. There's a reason you had to do that. It's so you could look at an equation and graph it. So that's what we're doing today. So the steps for this, I have them laid out for you, and we can kind of refer back to those as we go through each one. Number one, you want to make sure that your equation is written in slope-intercept form. Remember, that means y equals mx plus b, and you're going to want to identify the slope and the y-intercept. Identify the m and the b. Step two, place the b on the y-axis, so plot that point. Step three, starting from your y-intercept, use your slope to find more points in the line. So use the rise over the run from the y-intercept to give yourself one or two more points. So as far as rise over run goes, I know that you have dealt a lot with positive slopes, but in previous lessons we learned how to graph the negative slopes. So just remember that the top number, the numerator, tells you your vertical movement. If your top number is positive, you're going to go up. If it's negative, you're going to go down. The denominator, the bottom number, tells you your run. So if your bottom number is positive, you'll go right, and if it's left, or it's negative, you'll go left. Remember to start all your movement from the y-intercept. I realize that when you plot points, you're used to always starting from 0, 0, but when you're graphing a line, you start plotting your slope from the y-intercept. You need to start plotting your slope from a point that already exists on that line. Sometimes you're going to see a negative sign right in the middle of the numbers. We'll talk a little bit more about what that means, because it doesn't mean that they're both negative. So we'll talk about where to put that. At this moment, if you don't have a ruler or some kind of a straight edge, you're definitely going to need one, so you might want to press pause and get one. Welcome back. Okay, I have my ruler too. So let's take a look at these equations here. Our goal right now is to be able to graph each one, and the first one we have is y equals 2x plus 4. The good news is number one is all set for us. It's already in slope-intercept form. So our job is to identify the slope and the y-intercept. So in this equation, the m, the coefficient of x, is 2, and the b is 4. All right. Step one done. Step two says place the y-intercept, the b, on the y-axis. So it says b is 4. This is the y-axis. So I'm going to plot 0, 4. 1, 2, 3, 4. There's my y-intercept right there. Plot that point. Now it says I'm supposed to use the slope to tell me how to get from point to point. And we know that slope is a ratio of rise over run, correct? When I'm given a whole number, I'm not really seeing what the run is, but remember back to dealing with slope in Unit 3. I said write the slope as a ratio, and we left whole numbers over 1 so that this moment would make sense. When you're left with 2, that means that I have a denominator of 1. It's just written in simplest form. So if there's not a run, meaning there's not a denominator, you put a 1. If there's not a run, put a 1. There's my new poster that I need for my room. Vista poster printing will have to do that for me. So whole number, put a 1 under it. The 2 is positive, that means I'm going to go up. The 1 is positive, that means I'm going to go right. So from my y-intercept, I'm going to go up 2 and right 1. Now it doesn't look like I have enough room to go up 2 and right 1 again. And I would love to have 3 points on this line to make sure that it's accurate. So another way to do this, you can actually do the opposite of it. If I go up 2 right 1 to get to this point, go back to your y-intercept, you can go down to left 1 as well, and you see that that would still be a point on this line. The reason that it works, if I have negative 2 over negative 1, and I said simplify that, what would negative 2 divided by negative 1 be? 2, right? So that has the same value as this. So negative 2 over negative 1, that would mean down 2 right 1. So you can do either version of that so that you can give me 3 points. I only like 3-pointers. I'm such a baller. All right, there we go. We just graphed a line. When you graph your line, could you please extend it all the way through the graph and put arrows on both sides to represent this goes on and on forever and ever, just like some of these math lessons, huh? I know what it's like. Sorry. Okay, take a look at the second one. Yeah, we have a whole nother page of these too, so don't get too excited thinking there's only 3 examples. I just figured I'd burst your bubble early. Okay, I'm going to keep change. Step 1, I want us to identify the slope, the m. And when I look at the slope, I see that it's negative 1/4. Okay? If you see the negative sign in the middle, that means that either the 1 is negative or the 4 is negative. Because if this means division, isn't one of each how you get a negative with division? So if this fraction is negative, that means that one of those two had to be negative. That means I can either graph negative 1/4, or I could graph 1 over negative 4. Either one of those would work because both of them can be written as negative 1/4. The b, the number by itself, is a negative 1. So we've just figured out the m and the b. I'm going to put the word or here so you're not trying to think that it's some number that doesn't exist. I've never seen negative 1/4 1 and negative 4th before, but who knows. So b equals negative 1. That's my y-intercept. That's what I'm going to put on the graph first. So on the y-axis, I plot my negative 1. Now I need to plot my slope. It doesn't matter which one of these you pick. If I went and did the negative 1/4, negative 1/4 means down 1 because the numerator is negative and that's my vertical movement, and right 4. 1, 2, 3, 4. If I would have plotted 1 over negative 4, go back to your y-intercept, that positive 1 means up 1 and negative 4 means left 4. 1, 2, 3, 4. Do you see how those are all points on the same line? So when I say it doesn't matter where you put the negative sign, it really doesn't. And we started talking about that at the beginning of the school year. Isn't it amazing how everything ties together in math? I'm sure that's what you are thinking right now. Tee hee hee. Okay. Last one on this page. Then we have a whole extravaganza on the back because there's all kinds of different strange things that I need to make sure you're aware of. So here's my equation. Y equals 6x. It's solved for y, so that's great. The slope is given. It's a 6. 6 is the coefficient of x. It's a whole number, so when I don't see a run, I put a 1. And the b, there's nothing being added. And remember, when there's nothing being added, it's like saying plus 0. So this graph is going to start at 0, 0. So plot your b. There we go. And if I wanted to plot the points plot the rise over the run, this 6 in the top means up because it's positive. This 1 on the bottom means right because it's positive. So from here I would go up 1, 2, 3, 4, 5, 6, and right 1. And I like to have 3 points, right? 3-pointers. So if I have a negative 6 over a negative 1, that'll still simplify to positive 6, right? So go back to your y-intercept. I can go down 6 and left 1 and still be a point on that same line. So you can do opposites because basically it's the same slope, but you need to be able to move forwards and backwards. And again, always want the 3 points. 2 points just is not good enough. All right, next page. Turn it over. Oh, goodness. Yep, there's that x all by itself again with no coefficient. Poor thing. What are we going to do? Probably give it a coefficient. This is solved for y. I need to identify my slope and my b. Start with a b. This 4 is by itself. That's my y-intercept. Please do not write that the slope is x. The slope is not x. The slope is a coefficient of x. And what's the coefficient of a variable that has no coefficient? It's a 1. So my slope is 1. I do need my slope to be rise over run though, right? So if I don't have a run, I'm going to put a 1. So my slope here, 1 over 1. Y-intercept is 4. Plot that. 1, 2, 3, 4. And if my slope is 1 over 1, that means I'm going to go up 1 and right 1. Now if you want to, you could go down 1, left 1. Or if you wanted your 3 points, you can keep going up 1, right 1, up 1, right 1, up 1, right 1, from point to point on the graph. Keep moving, forwards, backwards. So you're either going up one, right one, or down one, left one, and you'll be a point on this line. So I think we've definitely got enough dots to make a nice straight line. Voila. All right, next, again, already solved for y. That's a beautiful thing. My slope in this one, there's not a number in front of the x. That means negative x really means negative 1x. So my slope is negative 1. And if you don't have a run, put a 1. My b, a lot of people right now want to write 1 because you know what we didn't do right away? We didn't keep change. The b is not 1. The b is a negative 1 because subtracting 1 is the same thing as adding a negative 1. That makes it negative. So I'm going to plot a negative 1. I'm going to put the b on this graph at negative 1. And if my slope is negative 1 over 1, that negative 1 on the top means down 1. The positive 1 on the bottom means right 1. If I wanted to, I could do the opposite of that and go up 1, left 1. Draw your line, and we see this line is going downward, right? And hopefully you remember from lesson 10-2, I think it was 10-2, if you have a line traveling down like this, that means it's a negative slope, and when you look at your equation, that is a negative slope. So that's a nice way to check yourself to make sure that you went the right direction. Okay, next one, again, still solve for y. This is nice. We'll keep change. This time I put the b plus the mx. That's okay. Your slope here, I see the coefficient of x is a negative 3. There's not a run, so I'm going to put a 1. And your b, the number by itself, is a negative 2. So plot your b. There's negative 2. If you have a slope of negative 3 over 1, that negative 3 for my vertical movement means down 3. 1, 2, 3. The positive 1 for my horizontal movement means right 1. I don't have enough room on this graph to go down 3, right 1 again. So remember that negative 3 divided by 1 is negative 3, but isn't 3 divided by negative 1 also negative 3? It sure is. So from my y-intercept, I'm going to go up 3, left 1, so that I can fit my third point. Draw the line. Nice straight line. Lovely little rulers. That's what they're for. Okay, almost there. Had to give you one with a fractional slope just to make sure we know what to do, especially when there's subtraction. So this is solved for y. That's great. I'm subtracting 3/4, so remember we've already done a lot of work with fractions. And I told you before, when you keep change it, go ahead and add the opposite and just put it with a numerator. It doesn't matter which one you put it with, but when you keep change, it doesn't mean that the 3 and the 4 are negative. It means one or the other is. So my slope for this, the coefficient of x, is negative 3/4. Or remember, we could also put 3 over negative 4. Both of those will simplify to negative 3/4. The b, the number by itself, is 1. So with this one, I'm going to go ahead and plot my y-intercept. My y-intercept is 1. So right on the y-axis, plot a 1 there. And I'm going to use both of those slopes the way we wrote them. So first, if we do negative 3 over 4, the vertical movement is a negative, so I'm going to go down 1, 2, 3. And the denominator in that first one is a positive 4, so I go right 1, 2, 3, 4. If I wanted to, I could also do the 3 over negative 4 and go up 3, left 4. Draw your line to connect those points. And again, do a little check. Do you see how we have a negative slope in our original equation? And this line that we just graphed is going down? That's good. It makes sense. All right. Next one here. Oh, y is not by itself. Don't tell me the slope is negative 5 and the b is a positive 4. It's not. Get the y alone. Here's the y. I need to get rid of this 4 that's being added. I'm going to add a negative 4 to each side. Y is equal to, don't write negative 9x. Please don't. It's not. The negative 4 doesn't have an x, so I'm going to write negative 5x plus negative 4. That is how we do it. All right, now, coefficient of x is negative 5. That means my slope is negative 5. I don't have a run, so I'm going to put a 1. And the b, the number by itself, that's a -4. All right, let's graph this. I'm going to start my graph at -4 because that's my y-intercept. So plot -4, 1, 2, 3, 4, there it is. Now my slope -5/1, this -5 means I should go down 5 and write 1, but aren't we out of graph? Yes. So -5 over +1 is the same thing as a +5 over -1. Don't both of those simplify to -5? Yes. So instead of going down 5, right 1, I can go up 5 for that +5. 1, 2, 3, 4, 5. And then I can go right 1. Left 1, sorry. I'm like, that's not right. So one more point, I'm going to do the same thing again. I'm going to plot the 5 over the -1. So up 1, 2, 3, 4, 5. And then left 1. Now if I was going from here to here, I would go down 5, right 1, down 5, right 1. If I'm going from here up, I go up 5, left 1, up 5, left 1. So they're all on the same line. That's why they mean the same exact thing. Hoping that's making sense. If not, we'll talk about it some more in class, for sure. Okay, last one. I know there's been a ton of these, but I really feel like it's necessary. We've been doing this a long time. I know you need a lot of examples of this. All right, I want y by itself. Step 1, get the y term alone. I need to get rid of this x that's being added. To get rid of it completely, I'm going to add a -x. I'm left with -5y on this side, and I'm left with 25 plus -x on this side. Okay, so -5 is in front of the y. I need that to go away. That means I'm going to divide by it. If I divide this by -5, that means every term over here needs to get divided by -5. So those cancel out. Y equals 25 divided by -5 is -5 plus, now this example is probably looking a little familiar to you, I'm hoping. I have -x over -5. Remember, this really means -1x over -5. I want my slope to be a fraction, and I see the fraction -1 over -5. There's my fraction. But I don't leave it as a negative over a negative, because in simplest form, a negative divided by a negative is a positive. So I'm going to write 1/5, and that's being multiplied by x. A little bit tougher, but not impossible. So my slope given by this one, the coefficient of x, is 1/5. The b, the number by itself, is -5. So let's go ahead and plot this. -5 is my b, so I'm going to go 1, 2, 3, 4, 5 down on the y. And a slope of 1/5. That 1 on top means up 1. The 5 in the bottom means right. 1, 2, 3, 4, 5. I don't have enough room to go up 1, right 5 again, but I can do what this says up here and go down 1, left 5. So from here, let's go down 1 and left. 1, 2, 3, 4, 5. You are still a point on the same exact line. Connect the dots. That's why you connected dots in your childhood, to get to this moment of linear functions. All right, good work. You are done. See you tomorrow.